When we look at transformations, as a rule of thumb, we should always think the easiest way to do transformations is flip and compression expansion first and shift last. So shift last is what we prefer, okay, when possible. This is not always possible. When we have the choice, we should do shift last. So in this example here, we're starting with a blue graph, this semicircle function, and we want to transform it into this kind of elongated, it's a kind of a half ellipse shape. Okay, so we're going to do the x's and y's separately. So the first thing we're going to do is we're going to look at what happened vertically in terms of this flip and expansion first, and then worry about the shift after the fact. Okay, so looking at the blue to the red, it looks like it's been vertically expanded by 3, because if I measure from top to bottom, okay, I have top to bottom is 4 for the blue graph, and for the red graph, I've counted 12. Okay, so it looks like a vertical expansion of 3. So when I look at my y transformation, I'm going to expand it by 3, and the first thing I'll do before I expand it by 3 is I'm going to flip it upside down, because I can see clearly that that red graph is upside down. So vertical flip, vertical expansion. Okay, that's my transformation. I flipped it, expanded it. Now I just got to figure out where the shift ended up. And to do this, I'm going to just keep track of one coordinate. And the one coordinate I'm going to keep track of is this one right here. That coordinate of 0, 4. And more importantly, it's y equals 4. Okay, now I just got to figure out where does it end up. It ends up down here at y equals -2. So I'm going to flip and expand by 3 and figure out where that coordinate ends up. And then I'm just going to shift it into the right position, because when I flip and expand it, I have the right orientation, I have the right shape. I just need to get it into the right spot. So to do this, I'm going to start with one coordinate. I'm just going to choose one point, and I'm going to start with y equals 4. So I'm going to start with this point up there, y equals 4, and I'm going to end at y equals 2. What happened in between? Well, the first thing that happened, and the order that it happened, was flip and expand by 3. Okay, so I kind of got it wrong here. I just need to fix that. It's going to be flip and expand by 3. So that means I'm going to times that coordinate of 4 by -3, and I'm going to end up at -12. So flipping gets me to -4, expanding by 3 gets me to -12, but in the end, that dot needs to be at -2. So what needs to happen? So that's the vertical shift that goes from -12 to -2. The shift that I need to get it in the right spot is a +10 shift. So then that's my vertical shift. I've got the right shape, and now in the right shape and the right orientation, now I have it in the right position. So there's all my y transformations. I did my flip and shift first, figured out the transformation of one coordinate, and figured out the last shift based on where my coordinate ended up after my flip and expansion and where I need to get to. So writing this in, it's going to be -3 on the outside and then +10 at the end. That's my entire y transformation. The x in this case looks a lot easier, because the x, I just need to start from 0, end up at 8. My x transformation is going to be x plus 8 from old to new, and then I just need to do it backwards for my notation. So x is equal to x minus 8, and this represents my notation, and I'm just going to plug it into my function notation then. So there it is. My f of x notation now looks like this: -3 f of x, and then inside is going to be x minus 8, and then +10 on the outside.